Ante la gran cantidad de conocimiento científico, cuando navegamos por Internet y cuando consultamos bases de datos biomédicas para buscar artículos científicos indexados y avalados por expertos académicos, pues es necesario poder seleccionar esa información de forma precisa y oportuna, teniendo en cuenta ciertas mediciones estandarizadas que nos permiten saber la calidad de la investigación científica, lo que se publica, de quién publica. Además debemos conocer y analizar la calidad de los artículos científicos, no solamente para medir el impacto de las publicaciones en el conocimiento científico mundial, sino esencialmente cuando hacemos un proyecto de investigación nosotros debemos recuperar artículos previamente publicados para saber cuál es mejor de cuál y cuáles debemos descartar. Adicionalmente, nosotros en nuestros propios proyectos de investigación debemos analizar nuestros resultados de manera crítica y debemos generar nuevas ideas. El producto final del proceso científico es necesariamente publicar en una revista biomédica. ¿Y qué mejor manera de ver cómo se refleja en la comunidad mundial del conocimiento nuestros artículos que utilizando nuestros índices bibliométricos para nuestras propias publicaciones? Si no, eso quedaría inacabada nuestro proceso de investigación. Después de haber realizado una búsqueda, una consulta en la base de datos Journal Citation Reports, habiendo seleccionado el año, según el editorial, el grupo de journals por área de conocimiento, entonces le arroja unos resultados. ¿Qué visualiza usted en los resultados? Uno puede observar no solamente el ranking de las mejores revistas, sino además su respectivo ISSN, el número total de citaciones, pero esencialmente le arroja índices bibliométricos importantes como el factor de impacto de la revista, su índice de inmediatez, el número de artículos publicados, el score Eigen Factor, el score sobre la influencia del artículo en la comunidad científica. Esos son algunos índices que usted debe tener en cuenta al evaluar no solo la revista, sino cada artículo que a usted le interese en su área de conocimiento.
As with any statistical data, bibliometrics is most effective when analyzed properly. The immense breadth and depth of this data leads to certain challenges, as publishing and citation data vary across categories and publications. As a rule of thumb, publications in different disciplines will be cited at a different pace, or, that is, have different citation behavior. And citation behavior may change over time. For example, in the life sciences, articles initially may garner a lot of citations, but will quickly taper off, whereas in mathematics, the citation counts are lower, but the same papers will continue to gain new citations for years after publication. Based on these trends, it would be unfair to expect a mathematics department to achieve the same rate of citation as the biology department. Therefore, institutions must find a way to fairly measure the performance of different disciplines. Older material tends to be more highly cited because it has simply had more opportunity to be cited. This complicates the process of comparing publications of differing ages. Researchers who have been publishing for a long time will be more likely to have a greater number of publications and more citations than an author who is newer. A direct comparison of the two will be biased in favor of the first researcher in this case. Citation distribution tends to be quite uneven, with only a small number of publications attaining highly cited status. Most publications have little or no citations. It is more than possible to mitigate these challenges by using relative versus absolute measures. The concept of relative versus absolute is crucial in understanding bibliometrics. Absolute counts include total publications, average papers published per year, and total citations received. These are concrete totals. Relative measures, such as citations versus expected citations, or rank within field or peer group, help to put metrics in context. For example, averages within a research field are usually generated using journal sets that serve to define the field. Such field definitions offer the advantage of uniformity and of measuring all within the same arena. These relative measures are an effective means for assessing a paper, multiple papers by a researcher, those of a team, and even those of an entire institution. Let's look at some more examples of relative measures. Because citation rates vary by field and over time, analyzing citation rates over time is a useful measure of comparison between different institutions. Within nanoscience and nanotechnology, the three institutions plotted on the graph have had various degrees of influence over the years. The y-axis represents the number of citations received. Around 1992, this institution had the lowest impact of all three within that discipline, but their influence grew over the years and peaked in 2004. Normalized citation impact is a measure of research field performance relative to the world average. An NCI value of 1 represents performance at par with the world average for the fields represented in a population. Values above 1 are considered above average, and values below 1 are considered below average. This measure can be used to assess the overall impact of an individual record or of a department or institution. Time span, subject area, and document type are kept static, so it can be a valuable and unbiased indicator of impact, irrespective of age, subject focus, or document type, and can allow you to compare the relative citation performances across different fields. Here is an example showing how to calculate the normalized citation impact of a paper. This paper is indexed in nanoscience and technology, as well as applied physics, and it was cited 28 times. On the right, we look at the number of citations the record received in each field, relative to the world citation average for each of the two fields. The average of those two fields is the normalized citation impact. A final point to keep in mind is that in bibliometrics, as with any statistical data, there will be no reliable performance assessment without sufficient data. The size of the data sample you want to analyze needs to be sufficiently large to extract meaningful information. The smaller the sample size, the more the analysis can be skewed by outliers. For example, consider an institution that wants to compare its departments. Being a school that focuses a lot of their attention on physics, they may be surprised to see computer science top their list of average citations. However, let's look at how this might happen. In this example, the physics department has published 103 papers with an average citation rate of 42.2. The computer science department has published 3 papers with an average citation rate of 58.7. This department had 1 very successful paper, but the average of the 3 papers does not accurately reflect the overall quality of the department's research output. In summary, when working with bibliometrics, it is important to remember that citation data varies across disciplines, over time, and between publications. Using relative measures tends to give institutions a more accurate means of making comparisons between their departments, between their individual researchers and research teams, and between their institution and peer institutions.